Hi guys, welcome back to the channel. In this video, I will be going through the isomerism topic of the A-level chemistry curriculum. So let's begin. So isomers, so these are molecules which have the same molecular formula, but they have a different arrangement of atoms. And there are two types of isomers. One is the structural isomers, and the other one is the stereoisomers. Okay, so we're now focusing on the structural isomerism first. So the structural isomerism are the molecules or compounds which have the same molecular formula, but they have a different structural formula. And there are three types of structural isomerism. So the first one is chain, the position, then the functional group one. Okay, so now starting with the chain isomerism, so you need to learn all of these definitions. These can come up. So these are compounds with the same molecular formula, but they have a different arrangement of the carbon skeleton. So for example, taking this into case, so both of these examples have the same number of carbon and same number of hydrogen atoms, so they have the same molecular formula. But if you look at their structure, this would be butane, because it has four carbons attached to each other and no methyl groups, whereas this example would be called a methyl propane because it has a methyl group. So this is an example of chain isomerism because they have different arrangement of carbon skeleton. So because there's a methyl group instead of being attached to a straight chain. And the next example is the position isomerism. So these are compounds with the same molecular formula, but they have functional group arranged in a different position. So focusing on the functional group now. So in this case, we have one chloropentane and two chloropentane. So they both again have the same molecular formula, and they have the same functional group, which is the chloro, but they are the functional group is in a different position. So for example, this is attached to the first carbon, whereas this is attached to the second carbon, and it could also be attached to the third carbon. This would also be considered as position isomerism. But for example, if it was on there, if the chlorine was attached to there, this wouldn't be position isomerism because they would still be attached to the first carbon atom. So next one is the functional group isomerism. So this is where the compounds with the same molecular formula but they have the same molecular formula, but the atoms are arranged in different functional groups. So the difference in this from the position isomerism is the position isomerism still has the same functional group, but the functional group isomerism has a different functional group now. So for example, in this case we have propanone. So propanone, it's propanone because the oxygen which is attached to the carbon, so the carbon has carbons attached to two other carbons. If it was only attached to one other carbon, then it would be propanol, which in this case it is. So this is a different functional group. Even though they have the same molecular formula, they still have one oxygen. They don't have anything else added, but because they have formed a different functional group, this is functional group isomerism. Okay, so stereoisomerism. So this is the second type of isomerism. So this is compounds with the same molecular formula, but the atoms are arranged differently in space. So we're looking at the 3D shape of the compounds. So in the AS level, we'll be only focusing on the EZ isomerism, so we'll ignore the optical isomerism in this. And this stereoisomerism occurs due to the limited rotation about the carbon-carbon double bond. So because the carbon-to-carbon double bond, it can't move around as it could with a single carbon-to-carbon bond. So that's why it creates a limited rotation, and that's why these type of isomerisms occur. Alright, so you need to know the priority rules to be able to name the EZ isomerism and to be able to differentiate between the different compounds. So the rule is that the higher mass has priority over the lower mass. So for example, if I have oxygen, if I have carbon, I know oxygen has an MR of 16, whereas carbon has MR of 12. So because oxygen has the greater MR, this would have priority over carbon. So there are two types of the isomers. So you can have the E isomers and the Z isomers. So the Z isomer have priority groups on the same side. So my teacher used to say, just imagine yourself being a German person saying same, we just add a Z instead of S, so we just say same side and Z for the Z isomers. And the other one's the E isomer, and this has priority groups on the different sides. So if we take in this butene as an example, we're looking at the carbon to carbon double bond, and we'll look at priority groups around that double bond. So for example, we have, in this case, this is the priority group as this has MR of 15, and this is the priority group in this side. So we split the carbon to carbon double bond in half and look at the carbon, we look at the priority groups around that. So again, so this has again an MR of 15, so whereas the hydrogen has an MR of 1, so this would not have priority. So the priority groups are on different sides in this case, so we would say that this would be classified as an E isomer because the priority groups are on different sides. Whereas if we're looking at the other example of looking at the priority groups, so for this example we have the priority groups on the same side, so we'd say this is the same side, and that's why this would be classified as the Z isomer. So we would say that this is Z butene and this is E butene. So just remember this rule.